Welcome to an introduction to acceleration, the acceleration formulas, and how we're going to solve a number of problems. So we have some example problems we're going to work out. So what you see on the screen here in front of you is 5 of the commonly used acceleration formulas. So the traditional one that you see that has Vf minus Vi over t. A reminder of what some of those symbols are. Over here you'll see the acceleration. We generally list that in meters per second squared, remembering that that's how fast you're speeding up or slowing down. It's a change of meters per second every second, which is equivalent to meters per second squared. That's the acceleration. So when you see that unit of meters per second squared, you know you're dealing with an acceleration. In questions where you have velocity in meters per second, you have to read contextual clues from the question as to whether it is an initial or beginning speed or whether it is a final speed. If it's the initial speed, we use Vi for initial, for beginning, what it starts at, versus at an ending period of time, you would use Vf, or a second speed. Your time interval in seconds is t, there's nothing new there. And your displacement, whether it has the triangle or not, displacement is your d variable, and that's generally going to be measured in meters. So you see the original acceleration. If you're looking for the final velocity, you'd usually use this formula here, where you could take the initial velocity plus acceleration times time. This is kind of like using an average velocity situation to get the displacement. If you want to get the distance traveled and you do not have acceleration, you can just add up the two velocities, divide by 2, and multiply that by time. You get probably what's known as the most complicated two formulas to deal with in this section. One of them has t's in the formula, and the other one has no time or no t. So sometimes when you're reading a question and it does not give you any indication of the time, this last formula is the one you're going to use. You really have to watch these squares, because you take the square of the final velocity is equal to the square of the initial velocity plus 2 times acceleration times displacement. And this formula right here, you'll use it a lot, and that is getting the distance that something is moving when it's accelerating. So you take the initial speed times time, and you add to that 1/2 the acceleration times the time squared. And you really just have to watch those formulas carefully and make sure you're applying them all right. So let's jump into first example and see what it is we're looking for. So we'll identify variables in the question, and then we'll choose the formula we need to choose appropriately. So here we see that a earth tremor has caused a large boulder to break free and start rolling down the mountainside with a constant acceleration of 5.2 meters per second squared. So this boulder starts to roll down the hill, and they give us an acceleration for that boulder of 5.2. So as soon as I see this unit, 5.2 meters per second squared, that indicates that it is an acceleration. So acceleration, area with an arrow, is a vector. 5.2 meters per second squared, and the only direction I'll put is downhill, because that's what it tells me that it's rolling. So downhill for the direction. They want to know what was the boulder's velocity after 8.5 seconds. That means it wants the velocity at the end of a period of time. So this question is trying to get you to solve for Vf. What is the final velocity after a time of 8.5 seconds? So if I go back to the question and try and see if there's something else in the context that we can get out here. We have that the large boulder breaks free and starts rolling down the hill. If it just starts rolling down the hill, then I think it's safe to say that the beginning speed is 0, because it just started to move. So that initial velocity we will put in as 0 meters per second. So we're looking for a formula that has VF in it, VI, A, and T. So you look at your list of formulas, and this one right here seems to be the one that will solve us for VF, and it uses VI, A, and T. So now that I've written down my data, I'm going to indicate which formula I'm using. I'm going to use the formula that VF equals VI plus acceleration times time. And now I'm going to plug in the numbers. So the VF is 0 meters per second plus the acceleration is 5.2 meters per second squared times the time of 8.5 seconds. And we're going to call downhill direction, let's call that positive direction. Okay, because that's the direction everything's moving in. So I'm going to leave this 5.2 right here as a positive number. I'm not going to make it negative. Alright, so really what you do, you take your 5.2 and your 8.5, you multiply those two together, and your final velocity comes out to 44.2 meters per second, because here you have meters per second squared, and here you have seconds. Well, seconds squared is in the bottom. A seconds on top means that one of those units cancels, and it leaves meters per second behind. So that answer is a positive that comes out in the calculator. Positive direction means downhill, so I'm going to put bracket downhill on here. So I've indicated the direction. It's obvious it's rolling down the hill. And the only other thing I guess I need to consider is I have 3 significant digits written here. I probably should write something a little bit better, because here I see 2 digits of significance. Here I see 2 more digits of significance, so this answer probably has to be rounded off to 44. So it's only 2 significant digits, meters per second and downhill. And that is a nice, tidy physics answer for the question. Okay, let's look at a second object going down a hill example. And this one is a skier. And the skier is going 8.2 meters per second when she falls and starts to slide down the ski run. So she's sliding here backwards down the ski run, and after a time of 3 seconds, her speed is 3.1 meters per second. So that's like part 1 of the question that I'm going to work out, is that my initial speed downhill will be positive. My initial velocity downhill is 8.2 meters per second. And when she slides for 3 seconds, the final speed is 3.1 meters per second. So she slows down, she's decelerating. The second part of this question, so that's like a part A. The second part of this question wants to know how long after she fell did it take her to come to a stop. So now it's it's asking for a time. How long does it take to have a VF come to a stop means VF 0. So we'll know the same VI, but we're going to need a bit more information. So what we can do is we can use, as part 1 of this question, we can use this information to get the acceleration, the deceleration technically, of the skier. And once we know the acceleration here, we can use it over here to answer the question. So step 1 is going to be calculate the acceleration. If you go and look at your formulas, there's a formula that says that you're going to take VF, subtract VI, and divide by T. Alright, so my acceleration is going to be the final speed of 3.1. Make sure you do these in the right order. Minus the initial speed of 8.2 meters per second. And you're dividing that by 3.0 seconds. So, when you subtract those two first, you get 5.1 and you divide it by 3, but you get a negative 5.1 divided by 3, so you get negative 1.7 meters per second squared, meaning meters per second every second. And it's in the opposite direction, it's slowing down. So that's technically uphill. The negative indicates that it's accelerating up the hill. You're not moving up the hill, but the direction of the acceleration's up the hill because you're slowing down. So now you can go to part 2 of this question. You can input the negative 1.7 meters per second squared, and you can say that you started at 8.2, and you want to know how long, t question mark, to come to a stop, and stop means VF 0. So we're going to need some room for this part. The formula that I have that links up acceleration, velocity, and time is this formula here that we're just going to write again. So if I know that acceleration is VF minus VI over t, but I want to know what the time is, well, I'm going to rearrange this formula by taking the t up and multiplying. Because it's being divided on the left, I'm going to bring, or on the right, I'm going to bring it up and make it a multiply on the other side. So AT equals VF minus VI. I'm still trying to get t by itself and upstairs. So I'll take A, which is multiplied by t, and I will take it down. So to get the time, you're going to do VF subtract VI over A. So effectively, if you compare this formula and that formula, you can just take the t and a and switch places next time you want to do this, a question like this, and solve for time. You just bring the t up and the a down. So now I'm going to plug the numbers into that formula and give myself a bit more room. So my VF is 0. Subtract. My VI was 8.2. And I'm going to divide that by the acceleration, which was negative 1.7 meters per second squared. And when you take negative 8.2 and divide by negative 1.7, you get a positive number, and it's positive 4.823. And that's a time, so it's in seconds. The meters cancel out, a bunch of the seconds cancel out, and it leaves seconds behind. Going back to the original data, the 8.2 only had 2 significant digits. The 3.0 had 2 significant digits. So my answer should be rounded to 2 significant digits. So you don't write all those numbers. You just write 4.8 seconds for the third one. Or the second question, sorry. So now the last one that we have is you're with your friend, you throw a rock off a cliff, but you don't throw it out on an angle, because that's a whole different set of physics in this question. You instead throw it straight downward. So the rock you're throwing is downward, and you give it this velocity down, 8.3 meters per second. At the instant you release the rock, your hiking buddy, who's probably in a physics class with you, starts a stopwatch. And instead of you hear, this question gets too complicated by actually saying you hear the splash, because that means the sound of the splash would have to come up, and it might very, to a small degree change the question. So let's say you see the splash when the rock hits the river below exactly 6.9 seconds after you threw the rock in. That way the question can just be simplified and we don't have to make it more complicated. This question wants to know how high above the cliff is it. So you've got this distance that the rock fell is the same as the height of the cliff. So you're really just trying to solve for distance. So D is what you're looking for. Unknown. You know the initial speed is 8.3 meters per second downward. And what else do we know? A time of 6.9 seconds. And we have to imply or infer in this question that it is falling, and we have to put in what the acceleration of gravity is. And the acceleration for anything that is falling downward, gravity is a constant acceleration that we put in as 9.81 meters per second squared down. And you will use that value in any question that something is falling or being dropped or thrown downward. Anything that gravity is working on, you can use an acceleration of 9.81 meters per second squared and in the downward direction. Gravity never points up, it's pointing down. Alrighty, so do we have the information to solve for distance? Well, there was only a couple of formulas for distance, and the one that we saw on that first page was the VI times t plus 1/2 acceleration times the time squared. And that's going to be a lot of numbers to plug in. So we have to pick what we're going to call these directions. We might as well, we often make downward negative. Let's make it negative for once. Okay, so let's say that down is going to be the negative direction. So I have to plug in negative numbers. So my distance is, my VI is going to be negative 8.3 meters per second. My time is going to be 6.9 seconds plus 1/2. My acceleration is also down, so you're going to put in negative 9.81 meters per second squared times the time squared, 6.9 seconds squared. So if I take the negative 8.3 and the 6.9 and multiply those together, I get negative 57.27 meters, because the seconds cancel. And in the other part of this, if I take the time squared, then times negative 9.81, and then divide by 2, I get a minus 213.66. And that's also meters, because second squared cancels with second squared. So you get a total distance that the rock fell of negative 270.93 meters. So the displacement of the stone is 270 meters down. But the question didn't want to know how far did the rock fall. It wants to know how high the cliff is. So you could say the cliff is 270 meters high. Remember, the negative was just showing you the direction. This is just because we chose down to be negative. That's the only reason the negative is in there. Okay, so, and that question has been rounded off. There were 2 significant digits here, 2 significant digits, and I immediately just rounded 270.93 to 270 meters. So that should be enough practice for you to try a couple of the questions that are going to be assigned out of the textbook, and hopefully you can have some success with these questions.